Okay, good morning, and today we're going to be talking about section 5.4, which is entitled More Trigonometric Graphs. In section 5.3, we studied specifically the sine and cosine graphs, so today we're going to look at tangent, cotangent, secant, and cosecant graphs to finish out the graphs for trig functions. Okay, so I would like for you to take just a minute and complete the following table here. So on this particular table, you're just asked to find tangent for each one of our values that we have. So I've got different values listed here. I want you to go through and calculate tangent. Remember, tangent is sine over cosine. Okay, once you've done that, you can see here that I've entered a couple columns here. I put the terminal point for each one of these t values that I have listed. So the terminal point coming straight from the unit circle is listed here, and I've calculated the tangent value for each of those points. So the tangent for this point, for instance, we're going to do sine over cosine, gives us 0 over 1. And so that's going to equal 0. But what you notice as we go down through here is that there are places where tangent's going to be undefined. So unlike sine and cosine, whose domain was all real numbers, tangent's domain is not all real numbers. And we have to, when we start doing its graph, we have to find those undefined places because they're going to become a vertical asymptote for us. So here at pi over 2, tangent's undefined, so we have a vertical asymptote at pi over 2. Again, down here at 3 pi over 2, we see that it is undefined, and therefore we have a vertical asymptote at 3 pi over 2. One thing I want you to notice also is that once we pass pi, these values start repeating. So it goes 0, 1, undefined, -1, 0, 1, undefined, -1, and then it just keeps going over and over again. So the period for tangent is actually just pi and not 2 pi. Okay, so because it repeats a little bit faster than sine and cosine, its period is different. So for sine and cosine, the period is 2 pi, but for tangent and also cotangent, the period is only pi because it repeats quicker. Okay, so we just talked about that tangent's going to have vertical asymptotes at these places. So we want to put this all together and see what the tangent graph looks like. If we come in here and we put a vertical asymptote at pi over 2, we would also come over and put one at 3 pi over 2 if we were graphing it that way. But what typically happens, and more of just a standard way of looking at the tangent graph, is we look at it over the period that goes from negative pi over 2 to positive pi over 2. So if you think about on the unit circle, negative pi over 2 is the same location as 3 pi over 2. So it's also going to be a place where the vertical asymptote, where you'll have a vertical asymptote and where tangent is undefined. So every pi units, so if we start here at negative pi over 2, every pi units we're going to repeat, okay? And so that's why we have a period of pi. So the difference between here to here is pi. When you go through and look at all the different x values and find the tangent of each one, what you'll see is that it takes on this general shape here. It passes through the origin, and as it gets closer and closer to the vertical asymptotes, it's going to, as it approaches on the x, the y is going to get closer and closer to that vertical asymptote. Same thing going down in this direction. So keep in mind that tangent rises. So from left to right, it's going to rise as it goes through this cycle here. Okay, so we just talked about that they have a period of pi. So basically by the periodic properties, the tangent of x plus pi is going to take you back to the same value of the regular tangent function. Same thing for cotangent, x plus pi, you're going to end up back where you started because of the periodic nature of it. So those have a period of pi. Cosecant and secant, because if you remember, cosecant is going to be 1 over sine, secant's 1 over cosine. So sine and cosine had periods of 2 pi, so that means that cosecant and secant are also going to have periods of 2 pi. So the only ones that have a different period are tangent and cotangent, and their period is pi. Okay, so this is just kind of demonstrating the periodic nature of the tangent function. So while we typically view this center one as the graph of tangent, because of the periodic nature, this repeats over and over and over. So we're showing 3 periods of the tangent function, but there's infinitely many periods of the tangent function that we could look at if we extended our graph far enough. Okay, so like I said, this is kind of the standard one from negative pi over 2 to positive pi over 2 that we'll generally focus on. Okay, the cotangent graph, by the same rationale, is going to end up having asymptotes. Here, I'm going to go back here. Having asymptotes at 0 and also at pi. Those are the places that cotangent would be undefined if you looked at the values like we did for tangent, and I'm not going to go through that again. But basically, you end up with asymptotes at 0, at pi. And by the periodic nature, since it has a period of pi, we would also have an asymptote at 2 pi, at 3 pi, at negative pi. So every pi units, we're going to have another vertical asymptote. Okay, this one with cotangent, notice that it falls, it goes down or decreases from left to right. So tangent increased from left to right, cotangent decreases from left to right. Okay, so this is showing several periods of this. The typical period that we want that you'll see used for cotangent is from 0 to pi. So this one here is kind of the one we call the standard one, so to speak. All these others are just repetitions of that basic one. But if we're focusing on just one, it's typically going to be this one that goes from 0 to pi. Okay, so starting to talk about the graph of secant. These graphs are a little bit more complicated, so I want to go through kind of how they come about. Secant is the same as 1 over cosine. So when you're doing the secant graph, the first thing that I want you to do is to think of if you were to start by graphing the cosine graph. So the cosine graph starts at 1 and makes this big valley. It goes from 1 all the way down to -1, back up to +1. Okay, once we have the cosine graphed, then we notice that cosine hits the x-axis here and it hits it here. Okay, so those are the places that cosine is 0. But it's also the places that if cosine is 0, it's the places where secant is undefined. So those places where cosine hits the x-axis are the places where secant is going to have a vertical asymptote. Okay, so this point here on cosine translates into an asymptote on secant. Okay, and same thing here. So we've got an x-intercept here for cosine, and therefore a vertical asymptote for secant. Okay, so everything we have graphed in blue is just simply aids for helping get the secant graph. It's not the secant graph itself. So once we have all this kind of graphed in here, then what we'll do is we'll, at the top and at the bottom of this cosine graph, we're just going to start and we're going to graph this up, and it's going to get closer and closer to this vertical asymptote. Down here, because it's on the bottom, we're going to go in the opposite direction. Okay, and again, it's going to get closer and closer to this vertical asymptote. Same thing over here. We'll start at the peak of our cosine graph, and then we'll take it closer and closer to the vertical asymptote. Okay, so this is just a graph of what secant looks like. So it's taking out that cosine graph that we started with, and you can see that you do have the periodic nature of the function itself, so it does keep repeating. So one whole cycle of it, or one whole period, would include both a top part and also a bottom part here. Typically on these we do from 0 to 2 pi, just like we do with sine and cosine. So, but this is showing a little bit more of that to show its repetitive nature. Okay, so for cosecant, cosecant we know is 1 over sine. So when we start to do cosecant's graph, we're actually going to do the same thing we did with secant. We're going to start with its reciprocal function. So we're going to start with the sine graph. So we know that sine starts at the origin and it goes, it's like you have a mountain and then a valley with that. So we'll start with the sine graph. And then everywhere that sine touches the x-axis, those are the places that sine is 0. So if sine is 0, if this is 0 here, 1 over 0 is undefined, and so that's where our vertical asymptotes are going to go. So even though you can't really see it, there's a vertical asymptote down your y-axis. We've got another vertical asymptote here, because these are the places where it touches the x-axis here. And also over here, we'll have another vertical asymptote. Okay, so once we have all that, then we'll just go to the peak and we'll go up with that same general shape, go to this peak and go down. And there we have our basic cosecant graph. Okay, this is showing a little bit more than just a regular standard period, as you can see that here we have one complete cycle being shown between negative pi and pi. We have the bottom part and we also have the top part. But if we go further, we do see that it starts to repeat. Okay, this is just a summary of what we've already talked about with our even and odd functions. So we have two that are symmetric about the y-axis being your even functions. That would be cosine and secant. So their graphs are going to be symmetric about the y-axis. These are all going to be symmetric about the origin. Okay, so that's what we've looked at so far is just the basics of these four new trig functions. So now I want to look at, sometimes you have period changes, just like we had period changes with sine and cosine. So when they stick this k in here, okay, it does change the period. Okay, so before when we were doing sine and cosine, the period would be 2 pi over k. Okay, because 2 pi was the standard period for sine and cosine. But in this case, when we're talking about tangent and cotangent, the standard period is pi. So we start with pi in the numerator and divide it by whatever the k is. So always do the standard period for that particular trig function divided by whatever the k is, and that'll give you the period. Okay, so as far as like what we the period that we're going to show when we graph these, typically for tangent we look at from negative pi over 2 to positive pi over 2, but when we have a k stuck in here, it's actually going to change that interval, and so we're going to multiply that 2 in the denominator by whatever the k is. And same thing with cotangent, we typically show from 0 to pi for a standard period, but here we're going to go 0 to pi over k as far as how that changes it. Okay, if we look at these examples here, we've got two tangent graphs that we're working with. The k in both of these is 2. So we know that we're going to have a period change because of that. So here's the k's. This one actually has a phase shift. So this one, for the phase shift, it's going to be to the right pi over 4. Okay. All right, so if we look at this first one here, okay, the tangent is tangent of 2x, so k is 2. So if we want to find the period formula for tangent is pi over k. So we put 2 in for k and we'll have pi over 2. We typically graph tangent from negative pi over 2 to positive pi over 2, but because we have this k, we're going to have to adapt that a little bit. So it'll be negative pi over 2k. So put the 2 in for the k. So we're going to show a graph from negative pi over 4 to positive pi over 4. So if I pull this graph up here, you can see that we still have that basic tangent shape to it where it rises from left to right. And we just kind of squeeze in our asymptote. So instead of them being at negative pi over 2 and positive pi over 2, we've got a horizontal shrink going on. And so it all kind of shrinks in. So our asymptote moves from where it normally would have been at pi over 2, it moves into pi over 4. This one at negative pi over 2 moves into negative pi over 4. So they all move in with that horizontal shrink that's going on because of this 2. Okay, this one we already said was a phase shift to the right pi over 4. So what we'll do with this is we were normally looking at the period being from negative pi over 4 to positive pi over 4. So because we're shifting it pi over 4 units to the right, we're actually going to add pi over 4 to each one of these. So if I add pi over 4 to this one, I'm going to have 0. And if I add pi over 4 to this one, I'm going to have pi over 2. Okay, so whatever the phase shift is, if it's to the right, you're going to add, and if it's to the left, you're going to subtract. So take the same, going back here, take these same values that we had just calculated, and since the only thing we're doing new here is shifting it to the right, we'll take this and just add the pi over 4s to those, and that will give us this new interval. And you can see this is we have an asymptote here, we also have one here, and it's going to be shifted to the right. All right, here's one. This is cotangent, and you've got the vertical stretches on these type graphs really doesn't, I mean, it still stretches it, but it's going to be harder to actually see that in the graph itself. We look at this, we need this 3 to be out in front of this parenthesis. So that's the first thing that we want to do is take the 3 out in front. When I pull this out, that's factoring out its, I won't say GCF because we just need to make sure this 3 gets factored out. So factoring is division. So we're going to take and divide this pi over 4 by 3. If I divide pi over 4 by 3, I'm going to get pi over 12. So I end up with a k of 3, and I also end up with a phase shift to the right pi over 12. Okay. So with cotangent, we typically look at 0 to pi. Okay. But on these, because we have a k, it's going to be 0 to pi over k. So since our k is 3, our interval is going to be 0 to pi over 3. And then if we take care of our phase shift to the right pi over 3, we're going to, or sorry, right pi over 12, then we're going to take and add pi over 12 to each one of these, and we'll end up having the one period being from pi over 12 to 5 pi over 12. Okay, so here's kind of an explanation from the book. And if we look at the graph itself, here's the graph itself. So cotangent, we know, decreases from left to right, so we get that decrease. Our normal period of this would have originally been 0 to pi, but because of the 3, it was going to be 0 to, see, we said that, sorry. Okay, so our period would have been normally, with the 3, it would have been to pi over 3. So looking back at all that. Okay, and then because of that, because we have this moving it to the right, we said we move it to the right pi over 12. So we're going to take and add those, and you can see that our interval that we're looking at here is from pi over 12 to 5 pi over 12. Okay, so we get this interval here that we're looking at, and then it just repeats after that. Okay, so for cosecant and secant graphs that have a k in those, our interval that we'll look at is 0 to 2 pi over k, and the period would be 2 pi over k. So just on the period, always remember it's whatever its normal period would be and divide it by the k. Okay, so for this one, we've got cosecant. We have a k of 2. Okay, so the period is going to be 2 pi over 2, or just pi for that. Okay, so if we look at this, like I said, the period is going to be 2 pi over 2, or pi. The standard window or standard interval that we would look at is 0 to 2 pi. Divide this one by k, and so we'll have 2 pi over 2. So our interval we'll look at is 0 to pi. So if I look at the graph for that one, okay, so here's the graph of the one that we were looking at, the 1/2 cosecant of 2x. And you can see from 0 to pi is one complete cycle of the of this 1/2 cosecant of 2x. Okay, if we look at the second one here, we've got y equals 1/2 cosecant of 2x plus 1/2 pi. So we need to take this 2 out, so we'll factor that out. So a 2 is going to be the k. That leaves us with a pi over 4, because if you remember in the previous example, when we factor out, factoring is division. So if I divide pi over 2 by 2, we get pi over 4. Okay, so k is 2, and we're going to have a phase shift to the left pi over 4, because we have this positive here, it would be to the left. So the interval that I'm going to look at is from 0 to 2 pi over k. So 0 to pi is the interval here that I'm going to graph my this particular period on, from 0 to pi. Since it's a phase shift to the left, I actually need to excuse me, subtract pi from, okay, so I'm going to need to subtract pi over 4 from each part of this. So 0 minus pi over 4, since that's the left phase shift, and then pi minus pi over 4. So when I get those, this will be negative pi over 4, and this will be 3 pi over 4. If you're having trouble evaluating something like this, put it in your calculator, but don't put the pi in. So just put 1 minus 1/4. So 1 minus 1/4 would be 3/4, and then stick the pi beside it. Okay, so we want to take a look at its graph here. So this is the graph that we were looking at, and we just said that we would one complete interval, which is the one in red here, is going to be from negative pi over 4 to 3 pi over 4. And that was that interval that we calculated. Cosecant is going to have this general shape to it. So just be sure you're kind of keeping the general shape correct, and you should be able to match these up. So obviously through WebAssign, these are going to be multiple choice questions, and you can definitely use the assistance of your calculator to figure these out as well. But these are the type things you need to look for. The K, how the K is going to change the period of the graph is really important. Okay, we've got y equals 3 secant of 1/2 x. So here our K is going to be 1/2, and we'll need to figure out the period. So the period is 2 pi over K, so 2 pi divided by 1/2 gives me a period of 4 pi. So because this K is less than 1, it's actually going to stretch the graph out and be a horizontal stretch instead of a horizontal shrink with that. So one complete period would be 0 to, instead of 2 pi, it would be 0 to 2 pi over K, so 0 to 4 pi. Okay, so here from 0 all the way over to 4 pi, we see that we have our secant graphed in here. So it's just stretched horizontally out from 0 all the way to 4 pi. And the 3, it is a vertical stretch. We haven't really talked a lot about that. It just means these get stretched a little faster, a little steeper. But the basic shape of your graph is not going to change a whole lot. One thing you'll notice on WebAssign is maybe the scaling of the y-axis is a little bit different, but it's not really going to change a whole lot of that. One difference that it will do, though, is because it's a 3 here, it's actually stretching the cosine graph that created the secant graph. So where the cosine graph would have normally started at 1 is actually starting up here at 3. And so you will see it change the y-intercepts a little bit, but that's really the main difference that you're going to see.